Morning, good afternoon, good evening. How are you doing today? Welcome to another episode of This Dev Life. If you're just coming for the very first time listening to this podcast, welcome and thank you for coming. If this is not your first time, thank you very much for coming back. Today on the show, I have an exciting guest and a very exciting topic, especially for software engineers, managers, and anyone that thinks around it. It's a developer show talking about developer life, challenges we face, and today the topic is not actually about developer life, maybe kind of in a way. We have today joining us from Accra, Ghana, Frank Udum, talking about software engineering ethics. Mr. Frank, how are you doing today?
Hey, hello, Dara. I'm doing great. You?
I'm doing well. I'm doing really good. It's a very bright, beautiful day, 21 degrees. Hottest the year so far, which is
Okay,
really exciting.
good for you. I'm
Yeah.
around
So,
30 degrees Celsius around here.
oh boy. Okay, you're enjoying. Summer is already here then.
hmm
Okay. Now, Mr. Frank, let's actually get to meet you first before we delve into the discussion for the day. Who is Frank?
Okay, so a small background about Frank. I'm a software engineer, and currently I'm more into consulting. So what I do on a daily basis is I try and I help people, build their software. So basically, all I do is I gather client requirements, and I have an awesome team I work with. Then once I get the requirements, we try and transform those requirements to exactly what the client needs. So usually, I'm more involved lately in managing the teams I work with than actually, writing most of the code myself. But I came from a very strong software development background, and I also did a bit of finance as well. So mostly what we do build are mostly business applications and um, software for startups. So like startup founders, if you have your idea and you probably want to build your startup, and you don't have a technology team to help you build that. So what I do is I come in and I work with founders like that, and I give them the team, I manage a team, and at the end of the day, their goal is to build that product or that dream product for that founder. So usually these are the things that I'm involved in on my daily basis, aside community work and being a dad. Yeah.
Yeah, the dad part is the check part for me.
Yeah.
Yeah. So you write code. Well, not so much anymore. You manage coders now. We're having this interesting discussion around what developers or programmers, engineers, whatever you call yourself, should
hmm
be, and how they should be. I cited this example of someone. Well, I was looking for some remote roles at that time, and then someone reached out to me and was like, "Okay, Dara, I want you to go to an interview." I was like, "Okay, cool. Interview, remote job, fine. We'll be earning lots of dollars." And I
hmm
was like, "Okay, but you're not going as Dara. You're going as me." I'm like, "Dude, that is impersonation." Yeah, I could literally go and say, okay, yes, this is this guy. We probably have the same accent. So I'll just pass the interview for you and then you get the gigs, you give me the money, we share our cut, everybody goes their way. Happy idiot. But I couldn't just do it. The fact that my Christian aside, the fact it just doesn't sound like something that was acceptable,
Yeah.
just morally, to do for me. And coincidentally, around that time, you made that tweet that okay, what do you think are software engineering? Then I started and I was like, dude, we cannot just talk about this between ourselves or just keep it to Twitter. I was like, okay, let's come on the show and actually talk about this. And
hmm
listeners will be talking about software engineering. So if you're a programmer manager, software engineer, senior software developer, senior software engineer, anything that has to do around coding, we'll be talking about that today. What are the ethics that should actually guide you? Actually, I didn't know these things actually existed until we had that chat. I was like, okay, we could actually have a talk around this. So I'm gonna hand the mic and the show all over to you now to talk all about software engineering ethics. What should guide a software engineer as they write code every day? Over to you.
Okay, great. So this this is a very interesting topic, and it's something that has really sparked a lot of my interest because Coming from, I mean, or even though I'm still in the engineering background, there are a lot of things that are being done that sometimes we don't know are the right or wrong things. So sometimes we fall victim to, certain things, right? So I have been doing a lot of research in other aspects of engineering, which is not just the coding or the other the usual stuff, but looking at delving into things like ethics. What is actually right in terms of software engineering and what is wrong? Um, so what I have for my presentation today is just to break down the whole profession that we are into as engineers and as developers, and to see what we need to do, right? So every profession needs to be guided by some ethics, right? So if you look at professions like medicine, right? Medicine has certain ethics behind it. So as a doctor, there are things you can do and things you can't do, right? And when you do the don't, there are certain sanctions that come to it, right? So as engineers, we have also set we have similar responsibilities as software developers. So we should also be aware that there are certain things we can't do, right? And there are certain things we can do, but the problem I've seen so far is that the can't do's for us don't really have any direct sanctions or implications. So we sometimes tend to
Mm.
just look over it, or just, just brush it to the side. So the goal of today's presentation is to just delve into some of these things and, have a discussion on it. And from now on, after the presentation, we get to know, okay, as a software engineer, what am I supposed to do and what I'm not supposed to do. And one clear distinction I'll be making is the difference between a software engineer and a developer or a coder as well. So most of us don't know there's actually a distinction, right? So I'll just go straight into it. So we are talking about software engineering ethics. Me being a teacher, I would like to break certain things down before I get straight into the topic. So first of all, let's look at what engineering is. So if you look at some of the definitions of engineering, you come across things like use of scientific principles to design and build things like machines, structures, software, or other items. So whether it is a bridge, a tunnel, road. I mean, once you are using a scientific approach to that, you can call that engineering, right? So if that is engineering, then who is an engineer? So that's the next thing I'd like to get into. An engineer basically is a problem solver. So somebody who organizes, communicates, or designs, right? So someone has all these skills to perform the engineering task, right? So we looked at the definition of engineering. So somebody who can understand and follow scientific principles to arrive at a goal. So that's what an engineer is. Now, before the whole talk about software engineering, right? We're just building, we're just developing, we're coders, just developers, just building stuff. I'm sure writing assembly or COBOL or Pascal, whatever it is back in the days. Then we realized that the industry realized that there was a big problem. And what was that problem? The problem was that most of the there was an issue of bad quality, right, in the end product or in whatever we build. There was poor quality in the software that was being presented. So then they decided that no, let's just look back into it. What are we getting wrong? Then they realized that no, we need to take a different approach to the way we build software. So that's when the whole discussion on software engineering came about. So initially there was a problem of projects failing because they couldn't meet timeline, projects failing because they over exceeded budgets, projects failing because
Mm.
developers or coders were not, building in a certain way. There was no maintenance, there was no testing. So now there was a discussion around software engineering. Okay, so let's look at what software engineering is. So software engineering basically is just the detailed study of engineering to designing, developing, and maintaining of software, right? So as you can
Mm.
see, it's a scientific process. Okay, so I've said that the software engineering was introduced because of low quality in software products or software projects, and budgets were being exceeded. And I mean, there was just a poor process in how we're building software. So now the industry came about with software engineering, and through that we introduced the software development lifecycle, right, which is part of engineering. Okay, so now we developers or we coders now are taking a scientific approach to how software is being built. Okay, so the software development lifecycle is just a series of stages in software engineering to develop a proposed software. Okay, then we have the various stages. We might not delve deep into what SDLC is, but we have various stages like requirements gathering, feasibility study, system analysis, software design, then coding. So as you can see, coding itself is part of the software engineering process. So as I said, we are going to actually establish the difference between the two. Then we have testing, and in other areas you can look at stuff like integration and operation maintenance and disposition, etc. So what it means is that software or development has now taken a scientific approach, meaning that you don't just get up and
Mm,
just build the software, right? We need to go through a process. We need to first plan, we need to gather requirements, we need to design, we need to write our code, we need to test, very important. We need to test, and we need to maintain. We maintain because the software environment keeps changing. Frameworks change, operating systems change, protocols change, right? So meaning that whatever software that you have built today probably might not last the time of tomorrow. So you need to be able to maintain or constantly iterate over the life cycle to make sure that you deliver software that is current. Okay. So now that we've talked about the scientific approach, which is the software engineering itself that's going through all these SDLC processes to arrive at software. The problem this is to solve is what was created in the beginning, which was software was poorly built because it wasn't properly tested, exceeded budget because nobody drew timelines and all that. So that's what this scientific approach was actually brought in to solve. So, one thing we need to also establish is that anytime we see engineering anywhere, right, we need to understand that it's a discipline. So, if you call yourself an
mm,
engineer for that matter, you need to understand that it's a discipline, right? And it's also a scientific process. So, if you call yourself a software engineer and just haphazardly building software without testing, it doesn't make you an engineer because you are just writing
mm.
code and you are just shipping it out. You are not testing it, so it doesn't make you an engineer. You need to go through the thorough scientific process of building a software. So now, I mentioned the distinction between, I think, the programmers or coders and the engineers. So let's look at
Software
the
engineer.
difference. So basically, a programmer is more like a primary activity. It's more of targeted to one thing. Okay, let's say we are building a software. You need to deliver this feature. The programmer just picks it and he just delivers it, right? But an engineer is more involved in the complete process. Okay, so programming is
Mm.
just one aspect of software. It's just one aspect of actually the whole
Engineering.
software engineering process. Okay, it's just one aspect. So who does the requirements gathering? Who does all the other processes that we talked about? So the software engineering itself encompasses, or it's more like a superset, and programming is just like a subset. Because
A
mind you, when we
subset
are
of it.
building software, we are building software for people, and all that. We'll look at it when we look at the ethics. So the we need to be sure that whatever we are building is usable by people. And I mean, we build the solutions for people most of the time, or even if you are writing it for probably a machine to use or whatever, at the end of the day, it should be able to meet its requirements. Okay, so the whole idea of just writing code and the whole idea of writing code that works for a particular purpose also is able to distinguish the difference between the two. So, first of all, we need to know that a software engineer is involved in the complete process, and programming is just one process of the software development lifecycle, right? And as a software engineer, you need to be able to have like good communication skills because in terms of things like requirements gathering, it has to do with communicating with people and actually understanding what exactly they want and being able to deliver what they want. Okay, not just writing
Mm.
the code. So you can write code, but efficient code or code that is very useful is code that you can write for people to use, right? If you write a code and only the machine understands it and people cannot use it, you might probably not have achieved your goal as an engineer. Um, so knowing now that we understand what the software engineering process is and the whole profession around software engineering, now let's look at ethics. So what guides a software engineer? As an engineer, what are you supposed to do? Okay, now I'm going to take this from there's a body called Association of Computing Machinery Committee, right? Now they have professional ethics that guides software engineering. So I'm going to share the ACM's code also with the host so that we can make it available to everybody. Okay, so let's quickly go to it. Now, the reason why we are looking at software engineering ethics is because we need to understand that our job or our duty is a professional practice. Okay, it's a
Mm.
professional practice. Now, it means that whatever we are doing, we need to execute it as professionals. We are not just doing what we do, but we are professionals. So, if you look at other disciplines like accounting, they have the chartered accountants and all that. It's a profession. Okay, so engineering itself, we need to see software engineering also as a profession. Now, once we understand that, we need to know that as engineers, we need to commit ourselves to the software design development lifecycle, right? Which is analyzing, specifying, designing, and development and testing and maintenance of software, right? So it means that once you call yourself a software engineer, you should commit yourself to that scientific process, which is that SDLC we've talked about. So if you are watching me today and you're not practicing any of the items we have in the SDLC, you are obviously missing something out. So before you call yourself a software engineer, you should make sure that you have all those items there checked. Now, what ACM is saying is that before you call yourself as a professional software engineer, you need to be able to
Engineer.
commit yourself to this scientific process. It's very important. Commit yourself to the scientific process first. So you need to understand that everything in a cycle is important. You don't do one and forget it. You don't just build a software and say, "Well, let's test later when it goes to production." It's part of the process. You need to also test that as well. So now there are 8 points that the ACM has developed to sort of like guide our profession, right? Now I'm going to pick all these 8 points and I'm going to briefly explain them. And we realize that at the end of the day, there are certain things I'm sure you would have heard of before, or there are certain things that have probably hit you or you've experienced before. And now, after this podcast, you'll be able to say, okay, I probably shouldn't have done that. Or next time, if it happens, I'm probably not going to do that. Okay. So now let's look at the first one. The
Mhm.
first one talks about public. It says a software engineer shall act consistently, sorry, with the public interest. Now, acting with public interest is very simple. What it means is that anything that you build, first of all, you have to accept full responsibility for your own work. Okay, you need to accept full responsibility for your own work, and you need to be able to in terms of public interest, when you build any solution, right, it should favor public interest. So you shouldn't build something that is against public interest or something that is going to harm the public. Okay, so probably if you are supposed to build a software that is going to detonate a bomb somewhere, that human lives are going to be affected. Once is not in public interest, it means you should not venture in certain practices. Okay, so there are certain things you can also
Mhm.
do that can affect the economy as a software engineer. If you probably want to take down some servers in a bank or in your central bank to disrupt the economy, you are not supposed to do that because it's not in the public interest. for that to happen. So we should be able to avoid things like, um, let's say, any software that does not promote, um, like human positive human living. Okay, so if you know you are building a software that is actually going to deteriorate human life or is going to affect the environment in any way, you should not engage in such software practices. So
Mm,
basically, it's more about public interest. You should always have the public interest at hand. And before that, you should be able to take full responsibility of everything you do as an engineer. So it's very important. This is like the fundamentals. You realize that all the points I'm going to talk about are just going to be relating back to public interest. Why is that the reason? Is
mm,
because most of the software we build is going back to our environment. People are going to use it. It's mostly going to be used by people. So at the end of the day, people are very important as an engineer. You need to understand that you are at service to people, just like they tell the doctors, you're actually at service to people, right? So the same thing as an engineer, service, all these softwares you are building are being used by people. So you should be able to have people interests at hand. It's very, very important. So don't do anything that is going to prohibit human existence or is going to be negative in terms of the public eye. Okay. So now let's look at the second principle. The second principle talks about client and employer. Okay, so they say says that software engineers shall act in manner that is in best interest of their client and employer, consistent with public interest. So you see, public interest comes
mm.
back here again. This
We're
means that
doubling
if
back
you
to
are,
it, yeah.
pardon,
I said we're doubling back to
yes,
public
you are
interest
doubling
as we
back to
go
public
forward.
interest. So it means if you are working for someone, right? First of all, that person is part of the public, okay? So that person has employed you. You probably have a contract with the person. You need to be able to abide by their rules in terms of how they are supposed to operate and how you are supposed to work, in your environment. It's very important. So as a software engineer, you should be able to act in the best interest of your employer or your client or your employer's client, consistent with public interest. Now, we can't take away the concern of public interest because you can have an employer. I can get up today and set up a company that recruits engineers to probably hack banks or to build malicious software that hack banks. It doesn't mean because I'm an employer and the software engineer ethics is saying you should obey what your employer says and blah blah blah. It means that I should be able to carry out those tasks. As an engineer, I should know that
Mm.
if it's not in public interest, then I should
Public
not,
interest.
I should not even listen to that employer because whatever he's employing me to do is unethical. Is very important. That means it's very unethical. So we should make sure that whatever we are doing for our employers and our clients is in constant sync with public interest. So we are looking at things like being honest as an engineer about limitations, okay, and your experiences. I always say that if you're an engineer and you are given a situation, it's not every situation you have an answer to. Our company, what we do is we build bespoke software. So what it means is that we don't know what we are going to build tomorrow. Okay, somebody can come
Mm.
tomorrow and say, build me this, build me that, build me this, right? So what I first do is, first of all, look at the feasibility of the project, and I also look at the ethical side of the project. I'll share some experiences with you. Look at the ethical side of the project. Then I steadily check whether I have the skill set because I'm not the only one building, I have a team. I need to make sure that the team has the skill set to carry out this particular
To be able
task.
to build it.
Now, if
Mm.
I know we don't have the skill set, I don't need to tell the customer, oh, yeah, we can do it. We charge you X amount. The customer is also happy and excited, pays. Then I go and sit down scratching my head, and all my engineers are like, we don't have knowledge in this stack that you brought to us. At the end of the day, I'm going to waste someone's time and someone's budget. And we know that in
Money,
engineering,
yeah.
all that process takes time, and budget is also part of it. Time is also a part of it. So at the end of the day, I'm supposed to make full disclosure of me not having knowledge in that technology. Now, this is how I can go about it as a
mm,
professional. There's nothing wrong with saying, I don't know how to do this. I've not used this stack before. I could play around it and see
mm,
how best I can come around it and solve the problem. Okay, rather than saying that yes, we can do it when we know you cannot do it. Okay, so there are certain projects that we've had that I've told the customer, okay, we can just try and study it. We've never done a project like this before. That is the first disclosure. We
mm,
haven't done a project like that before. So meaning that we don't have knowledge in it. So how do we get the knowledge in that project? If you are willing to give us time, we can go in, research, understand, and build a POC. So we do a lot of POCs at my end. We'll build a proof of concept just for you to see that this is what we're able to come out with after studying the documentation, whatever you give to us. Are you okay with this? Now, if the client say, "Oh, I'm okay," you guys, I mean, this is exactly what I want, so you can go ahead. Then that is fine. But what if we went and we realized that okay, we are not able to do it, and probably it involves certain things that we are not vested in? We need to tell the client that well, it's a nice project, but looks like we don't have the skill set for that yet. So, I mean, we'll not be able to accommodate this project. It is good as a software engineer to always offer full disclosure. Now, on the other side, you are
mm,
going for a job, right? And probably they ask you, do you know how to do A, B, C, D? And you say yes, 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 yes. When probably you know you are not vested in that technology. It's better to say you don't and you can study it, or you're a fast learner or you can adapt, than to go and say you know it. And when you get to a certain level in the recruitment where you get to probably the technical recruiter who probably gives you or poses a problem to you in the area you said you were good in, which you stated in your CV, and now you'll be found wanted. So engineers should not behave that way. It's not, it goes against our practice as engineers. So other things are like when you are building for your employer and you are using third party software, you should make sure that that third party software is obtained legally. Okay, do not go and use a cracked
mm,
version of a software, and your employer will not be aware of it, and you ship it in a client's project, and the client is probably contacted by that vendor that, hey, we are suing you for cracking this software. We realize you are using a cracked version of this in your SaaS application. So you
mm,
should
software.
make all those things very fully disclosed. If you are using a software that needs to be licensed, you need to tell your employer that, hey, sir, we need to buy the license for this product because it is not free, and we cannot also crack because it's unethical. So these are some of the things you need to do
Mhm,
in terms of client and employer relationship. Okay, so let me just hammer on the last one. Promote the interest, adverse to client employer. In any case, if we have a higher ethical concern being compromised, right, you need to inform your employer or the appropriate authority
mm,
of that ethical concern. So now that we are learning about ethics, if there's any issue, because there are certain ethical issues you'll be on that your employer might not know. Okay, but you as an engineer can come
mhm,
out and say, hey, sir, this thing we are doing, doesn't it violate this patent or this, and your boss might reconsider it and say, oh, wow, I never knew, you know. So as an engineer, you should always, 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 always be able to express anything of higher ethical concern that is being compromised. It's very important. Okay, so let's move to products. As engineers, what do we build? All we are building are products. All these products we are building products, and who is going to use the product? Mostly human beings, right? So a software engineer
mhm,
shall ensure that their product and their related modifications meet the highest, I repeat, the highest professional standard possible. In particular, software engineers shall do the following, which I'll talk about. So one of them is like strive for high quality. This is very, 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 very important, because we are saying engineering is now a scientific approach. So the industry is like, okay, now let's go by a scientific approach to building software, because we realized that the quality of software was very poor, right? So now that we are going by a scientific approach, to build this product, we need to always abide by the highest standards. It's very important. So when you're building something that you know that this thing is not being built by best practice, when you think as an engineer, the first thing that concerns you is, hey, this thing we are doing, it might go down or it might not scale. You know, you are building a solution that will
Mhm.
not scale. You know very well that this will not scale. Instead of you to probably address the issue and build it according to best practice, you are like, oh, let's just ship this to the client. We'll think about it later. We are not operating with the highest standards. So we need to make sure that we always go with the best practices. So I always encourage my team. I always see that all these technologies we are using is being documented by the people that created it. So as much as possible, as an engineer, you should be a good researcher. So, as a software engineer, you should be able to maintain professional objectivity with respect to any software or related document you are asked to evaluate. So, if you are evaluating any software or any document, you should be able to have a personal objectivity with it, right? You should be able to sign off documents that
Mhm.
you personally understand why you are signing off, and you shouldn't just sign off without any understanding. So personal judgment is very important, right? In terms of um, you knowing even what is ethical and what is not ethical, you need to be able to, once you understand what is ethical and unethical, you need to be able to apply your judgment in any scenario or any use case that you find yourself in. Okay, so you also need to disclose to all concerned parties conflict of interest and all that can be avoided or escaped. So, as a good software engineer, you should be able to disclose things of like stuff like conflict of interest or any risk that can be avoided, because risk and all that come in to what increase the lifespan of the or the timeline of the project, and
Mm.
also increase costs. Okay, so as an individual professional, as an engineer, you need to be able to apply your personal judgment to certain things of this nature, so that if you know there's going to be a risk if we go this route, you should be able to say, hey, if we go this route, we are going to have a risk. Or if we are we ready to deploy the application? Is it ready? If you know the application is not ready, you should be able to tell and say that, hey, we don't need to ship this now. When we ship this now, we are going to have an issue. That's a clear case of
Mm.
what happened with the MCAS software that was supposed to prevent airplanes from stalling. Right, there was an internal issue with the software, but certain engineers became unethical and decided to look over it. And because their competitor was shipping out their product, they also
Just
decided
close
to
it without
just
testing.
push theirs out, right? But there was an issue with the software internally that they were aware of. Okay, so those engineers that had to probably, based on their judgment and their ethics, say, hey, we can't ship this product because we believe it's not ready, and
Mm.
also it might endanger human lives, right? Getting back to public interest, right? Because there was no ethical practice, what did they do? They shipped the software in the planes, they built the planes and they deployed them, and it brought down
Mhm.
two plane crashes and a whole lot of lives were lost. So as engineers, these are things that we need to do. So we are not just building stuff, or you build something small that will be used in a very big project in future, right? So we should observe this. Don't say that, oh, I build only small projects so this doesn't affect me and all that. It's good to build a habit now, because you don't know when something you build to be used elsewhere, or you don't know when you be called to build something that is
Yeah. I,
big
I,
and
I
will impact human lives,
I
right?
I think it's even
So you need to be
dangerous,
very
especially if
judgmental.
it's open source,
Hmm.
because most people just go pick this open source and then they deploy this
Yeah,
unethical open source code in SpaceX or somewhere, and then boom, rockets keep blowing up.
yeah, yeah. Yeah, yeah, exactly. Very good point. So yeah, so it could even be in the open source environment. You build something, if you don't follow these practices and be ethical about it, somebody can pick it as a Trojan, use it, and another attacker can go through your software and get to wherever they have to get to. So that's a very good point there. So yes, now let's look at the fifth point. Now, this is management, so goes to anybody managing or in a managerial position. So, software engineering managers and leaders shall subscribe to and promote an ethical approach to the management of software development and maintenance. In particular, those managing or leading software engineers, we should do the following. So now let me just state a clear example. So in my team, I'm responsible for enforcing
Just
software engineering best practices, right, and ethics, right. So as a manager or as a leader, you are supposed to lead your developers in the right direction, right. So if you're a leader and you're a manager and you're not having set discussions with your engineering teams, then you know that you might have a problem in future. Okay, now you need to steer your engineering team to understand that this is
mm,
best practices, this is ethics, this is ethical, this is non-ethical, right? Coders might not
mm,
think in that like, because their focus is just to put in a feature and just get out. But once they start thinking in this direction, they also start doing their research, and at the end of the day, we all end up building what a very good software. So you should ensure good management for every project that is being worked on, including effective procedures of promotion,
mm,
of quality, and reduction of risk. So very important as a manager. Always discuss risk with your team. Usually, I'll ask my team, is there any risk? Is there any risk? I keep asking because I am the one talking to the client on timelines, right? And they are building the software. So at the end of the day, if there's a risk, I should be aware that there's a risk. Then I need to be able to communicate that to the client. As I said, we need to be transparent. So you need to be able to communicate that to the client and first find the best approach, to that. An example is, let's say you are building a software, you are about to ship the software. This happened to us before, and all of a sudden, let's say it's an iOS, an Apple software, or an Apple app or an iOS app. Then all of a sudden, what happens is Apple ships a new update. You know, just ships a new update. Once you do your internal testing, you should be able to tell your client, "Wow, this new update that Apple
mhm.
just shipped is actually breaking A, B, C, D, and E." So even though we are set to go out now, we have a
It should not be
huge risk,
compatible.
because once you push this update, a lot of yes, it will not be compatible. People will have breaking changes. We've experienced that where Apple changed, I think in version 14, iOS 14, changed the way they were implementing their cameras. They brought better APIs and they changed a lot of things, because and the devices are getting much better in terms of cameras. They have 4 or 5 cameras and all that. So they did a little work around their APIs, right? So it was breaking our camera functionality. So you need to let your client know that, oh, this is what is happening, and if we ship, we might break, right? The developers need to let the managers also know, sir, this is what is happening. If we ship, we will break. And you, the engineer, as well, and the manager, need to carry that to your client. So as much as possible, you can find a way to reduce the risk. It's very, very important. And some of the risk, they might just appear suddenly. You need to communicate them and find the best way around it. So risk communication is very important on the managerial level. So you should also ensure as a manager that software engineers are informed of
Mm,
standard before being held to them. So that's why you need to constantly train your team on what is best and what is right, what is correct and what is wrong. You can't hold somebody to a standard if you've not informed them about it, or you've not carried them through any training process. Okay, probably what we are discussing, your engineers are not aware about it. But because tomorrow an issue arises and there's an escalation on the client level, then you begin to breathe down your engineer's neck. You're not supposed to do this, do that, do this. What this point is saying is that you need to be able to let your engineers be aware of these standards before you can hold them accountable to it. So, as a manager, if you are not communicating this to your engineers, please do not get up and tell them that this is what they are supposed to do, because we just assume they are not aware of these processes. So, you need to carry out that education. It's very important as a manager. And there are a couple of points I might not be able to go through all. You should be able to offer fair and just remuneration. Developers are motivated by, or not only
The right
developers,
amount of
even
money.
managers are even motivated by remuneration. Everybody actually is motivated by remuneration. So at the end of the day, you should be able to give your developers what you are worth. Okay. So I personally have this concept in my team where I always say that we grow together. So once the company is growing, everybody experiences the growth. I mean, as we go. So growth in your pocket as we go. So we work together as a team and we all get to a point where we can all enjoy, labors of our hard work. So as a manager, you should be able to give engineers what they are due, because it's not
Mm-hmm.
easy finding engineers who are loyal and dedicated and want to obey best practices and to follow your lead and be ethical and everything. So once you're able to identify such talents, you should be able to first of all put them in the right direction of knowing what is right, what is wrong, and you should only hold them accountable when you've already done that knowledge passing. Then secondly, you can now you need to motivate them, okay, with remuneration. So that's what the ACM is saying, because engineers, if not motivated, most of these unethical practices that happen, if you
Mm.
look behind it, the issue is always money. Mostly it's either money or ego. It's either money or ego. So probably something happens and this developer wants to get whatever, and then he decides to go and
I'll
delete
be like,
the
I'm not
whole
paid enough for
repository.
this.
you know so as a man so as a manager, these are things you need to be aware of, because these are guys that are actually handling the code and are responsible for the code and actually writing the code. So they might you might want to treat them well, and you might want to guide them in the right way so that they know what is right from wrong, you know so that somebody doesn't just end up deleting a repository, and at the end of the day it affects the whole world, like what
Mm.
happened on the npm use case. The guy decided to just remove his repository, and it broke the whole internet, because that library was called left pad. So a lot of frameworks and libraries were depending on other frameworks that were
Mm.
depending, and they all were using left pad. So when that guy decided to get pissed off and he just deleted his repository, the whole internet broke. I'll probably share a link to that. You can read that as well. It's interesting. So in a way, I'll probably just pose that question: was that ethical of the developer, or was that unethical? He had an issue with a company that wanted to use that same name he was using, and the company brought in their lawyers and said, "Hey, you know what? We want to take this name for our client." And the guy was like, "Okay, pay me 30,000 USD, and I'll give you the name." And they decided to go the aggressive route, the company, because npm was also trying to, I think,
Mm.
lean on their company side, because that was a corporate. And the guy was like, okay, well, let me just delete my repository. Shoo. He deleted it, and the whole internet got broken. So it was a very interesting scenario. So the question is, was that ethical or was that unethical? It's for you to judge. Well, let's continue. So where are we? So that's under managers. So that's what managers are supposed to do. Is there any other interesting one under managers? Yes, you should not punish anyone for expressing ethical concerns about their project. If you're a manager and an engineer comes and says, "Hey, sir, I believe what we are doing is not the right way to do it because it's going to jeopardize human life, it's going to have an effect on our environment," or "Sir, this software that we are building and we are going to install into these planes is not ready, and we've done our test and we've seen that we need to carry on more tests because all our tests are failing and the plane is not able to behave the way it's supposed to behave when it's in flight. So, sir, can we please withdraw
Love
and
it.
can we push back the delivery timeline because this might be an issue. So you should be able to come out as an engineer, and you, a manager, shouldn't punish any engineer for coming out, saying what is ethical. You don't need to punish any engineer for that because he's being ethical and he's drawing attention to what is going to cost human life, what is dangerous to the public. So at the end of the day, you should be able to listen to that engineer and do
mm.
not say that I'm going to sack you because of that. So that's very important for managers. Okay, so let's look at the sixth principle, profession. So ACM is saying software engineers shall advance their integrity and reputation of the profession consistent with public interest. Our friend public interest
Yeah.
is here again. I hope you can see that. Yeah. In particular, software engineers shall, okay, we'll talk about that, do the following. So it's very important that you see what you see yourself as a professional. Okay, you could probably Google what a professional means. You should see yourself as a professional. Now, a professional takes his work seriously. A professional follows principles. A professional is disciplined. Okay, so see yourself as a professional. Don't see yourself as a just somebody trying to do something. You're a professional, and you should operate in a certain way. Okay, so it's very important that engineers obey um, our engineering practice as a profession which is consistent with public interest. So help. So we are supposed to do things like help and develop organizational, environmental, help develop an organization's environment favorable to acting ethically. Okay. So if you look at the previous point, they were saying that you should not punish anybody for
Questions,
coming
yes.
out with any um, or voicing out any unethical. Yeah. So now this point is saying we looking at our practice as a profession. What we need to do is we need to be able to um, sort of help people or create that environment. Okay, so in your organization, create an environment where people can come and voice out. Don't create an environment where developers are not allowed to talk, right? So for me, I always have a problem if engineers are not communicating. I feel like there's an issue or there's a problem. So I always ask for input. I try not to impose. Okay, we are building together. We all have technical abilities. So everybody bring together your input. Let's evaluate it and let's see how we can build a system together. So in my team, we try not to practice the architectural matricist kind of one god
How's the control?
has the access to the whole system. One or one god is in charge of the whole project. If he says move this direction, we all move. If he says no, everybody is. So we create an environment where everybody can
Mm,
say. So we actually even vote. So like one of the team, we had a team call this morning where we had to vote. So what's happening is we are deploying a mobile solution for a client, and that mobile solution will only be used by the client. So my question was, are we deploying this on the Play Store, or we should just give the client a link in their backend portal where we can be releasing updates and they download it? Because my idea was if we deploy it on Play Store, 0.00000 less than 0.0001% of
and
people in Play Store are going
yeah.
to be accessing it because it's not for people on the Play Store, right? It's not for general consumption. It's just for a particular enterprise. So we had to vote on how we're going to deploy the app. Then somebody made an input saying that usually links are very cumbersome in installing apps because you have to install it, then you have to go and turn on privacy or what to allow you to install that app because it's not coming from the Play Store. Then we said, okay, we are going to look for a way we can deploy it through the Play
Mm-hmm.
Store, but we are going to make it closed. So we are going to experiment the closed user testing for deploying for that particular customer. So what it means is going to be on the Play Store, but if you don't have that
Mm,
email added as a closed test, you didn't have access to the app. So I had to vote, like,
yeah.
let's vote and let's see which one wins. So let everybody bring together their input. So always create such an environment as an engineer because engineering is a scientific process which involves communication. So you shouldn't be an architectural matricist when sit in one corner, design everything and come and just want developers to be like minions just to, follow follow your design pattern. You need to also ask for contribution from your engineers and see how best you create an environment that everybody can contribute. So that's very important. So I think that is it for profession. So we should obey all laws governing our works unless exceptional circumstances such as compliance and inconsistent with
Again.
public interest. Public interest is here again. So if you are building an application, yeah, if you are building an application in the health industry, so like an example, you are building an application that's going for copper certification, and copper has a certain in the US they have certain guiding rules whereby we are building an application for students. You're not supposed to be storing emails, you're not supposed to be storing this and that and that and that. So whichever body you are working with, you need to be able to be sure that you go with their guidelines. It's very important. So let's quickly move to the next step, probably because of time. Last but one is colleagues. Software engineers shall be fair and supportive of their colleagues. In particular, software engineers shall encourage colleagues to adhere to this code. So if you're an engineer and you're a manager, you create a good environment and atmosphere for your engineers to voice out on ethical issues. If you're a colleague, you should talk to your friend. Hey, with this package you are using, is it malicious? Probably there was an issue. I read it somewhere that there are certain backdoors here. Let's not use it. Let's go for this version. This is more secure than our client to be safe. You should be able to encourage your colleagues to do practice ethical development. Okay, you should assist your colleagues in professional development. If you are working with colleagues and their colleagues have issues in terms of their development, you should be able to assist them. Okay, it's a group
Mm,
thing. Software development, we build software in groups. So we should be able to assist each other, try and do peer programming. If you have a problem, seek the other developer's opinion and see what happens. Anytime we communicate, it's easier for us to carry out this whole best practice of being ethical. Okay, so credit fully the work of others and refrain from taking undue credit. Very, very important as an engineer. Anytime I have to do a presentation on behalf of my team, I always let the customer know that this is the good work of some engineers that I'm working with that build this. I don't take credit and say, "Hey, I built this. Yes, I'm the champion over this system." No, I rely a lot on the engineers I work with because they do
yeah, clear
mostly
code, yeah.
everything in terms of the practical coding. So I need to make sure that I give them the credit when it's due. It's very important as a professional. Don't That's a way of motivating your team. So sometimes I'm on a call with one of my team members and the client says, "Hey Frank, you guys you did very well on this." I say, "Oh, you know what? I didn't work on this. It was Kwame that did this." Or it was Daniel that worked on this part. Oh, Daniel, wow, that was good. I wouldn't take the credit for myself. It's very important because as a leader, if you take credit for yourself, I don't know what the word
Yeah,
is. You
people did
sort
the
of like
work.
demotivate your engineers from doing the best. Imagine you have a manager who is always taking credit for everything you do. You go and do the presentation. Yes, he's a manager, so
Hmm.
he gets to mostly do the presentation. That is his side of the job, right? But at the end of the day, put the credits and let the customer or the end person know, or whoever is doing the presentation know that there's an awesome team behind whatever you built. It's very important because some of the issues in the unethical practice, if you look at some of the use cases, you realize that some of it is because somebody was taking all the credit. So this guy's like, okay,
Bam.
now you they take all the credit, Abby.
We'll see where
Oh
the
yeah,
credit goes.
delete. It's just one simple action like this, hitting enter. He will just clear everything or probably make your life complicated as a manager, right? Because you are not giving him credit, and at the end of the day, you lose, the client loses, the company loses, and he, the developer, loses as well. So in order to prevent all these issues, we need to be able to understand it. So the ethical practice of engineering is very, very interesting. It's an area that I'm really trying to advocate for so that we can grow engineering teams that understand all these things and we can build some awesome software in Africa. Okay, so in situation outside your own area of competence, call upon the opinions of other professions who have competence in that area. I'll go back to medicine. I always tell my team that I see software development as a surgical operation, right? Where you have probably different surgeons specialize in certain areas or coming together trying to have like a successful operation, right?
Mm-hmm.
First of all, it doesn't take one person to do it all. Somebody needs to cut, somebody needs to hold, somebody is good with probably veins, somebody is good with anesthetics, right? It doesn't mean that the person who is doing the anesthetics is less important. If he
Mm-hmm.
doesn't give the client the right
Make the
dosage,
pen
he
big,
kills
make the
him.
pen big. Yeah.
Oh, yeah, because he needs to know the right dosage. Yeah. Or you be the patient will be in the surgery and you just wake up like all the anesthesia just wakes up and during the middle of probably an operation. Can you imagine? So it's very important that we as engineers are able to call on the competence of others, right? So if there's an issue you are faced with and you know there's another professional, there's a guy who is very good in databases, right? He's a serious database guru, right? And you have to work with him. You could consult him, his
Mm.
experience, and work with that person. That's how professionals work. If there's somebody who is good in distributed computing, right? Don't sit there and try and do your own distributed computing. If you have a big project, you can consult that person. Oh, I have this client who says he wants this and he wants this to be highly available. What is the best way I can go around it? Probably I know how to deploy to Azure and that is it. But there's somebody who is very focused in making things very scalable and highly available. Consult the person. So as a professional, you should be able to consult, in terms of other areas that you are not vested in. That's what doctors actually do. When you go and they diagnose and realize that this is a heart case, you go to the surgeon, whoever is expert in the heart or whatever, and say these are the x-rays, what do you think of this diagnostics? Then they listen from that specialist, they take the information before they're able to carry out what they need to do. So in the same way we should also go about our practice. Now the last point we have here is self. S-E-L-F.
SEL if.
I don't say S-E-L-F. S-E-L-F. Elif, yeah. The My brain was getting confused. So SELF. So self, very important. So software engineers shall participate in lifelong learning. The word is lifelong learning regarding the practice of their profession, and they shall promote an ethical approach to the practice of their profession. In particular, software engineers shall further their knowledge in development, analysis, specification design, maintenance, testing, software related documents together with the management of the development process. This is very, very important because if you don't continuously upgrade yourself, right? Technology is moving so fast that the tech from
Mm.
yesterday might not be the tech for today. Today they are saying MDF5 encryption is not the best. Tomorrow they'll say, hey, let's move to SHA-1. You move to SHA-1, they say, hey, you know what? SHA-1 has some small vulnerability now. It's SHA-2. The same thing they'll say for TCP and TLS and all those protocols. So once you keep studying and you understand them, even though the old
Mhm.
ones are still there because they are relevant for certain scenarios, but because you understand it, you apply what is most suitable. So if a client wants to build a highly encrypted environment, you go and use MD5, you know, because even though MD5 is still existing, it's not been outmoded or obsolete for a reason, right? So you go for the best encryption, whether it's AES or whatever it is that fits you, right? And you use that. Okay, so the thing is that as an engineer, you need to understand that it's a continuous process. Everything in the software engineering lifecycle is a scientific process. Science changes because the earth
The
itself
evolution.
changes
Correct.
in terms of how things today. The climate back in the days is not the same as the climate now. Things are adjusting. The way we ate before is not the way we eat now. So the way software behaves then is not the way software behaves now, and it's not the way it's going to behave in the future. So as a good engineer, you need to always build a habit of continuously investing in what you do in terms of your software process. You need to be able to understand all these things. Let me see if I can pick an interesting one. So, improve ability to produce accurate, informative, and well written documentation. So this is another interesting part because it's a scientific process. What happens in science? Um, they do their research, they come up with something, and there's always some writing or some finding. Hey, this is what we found. This is how you can go around it if you want. So the same thing for software engineering. At the end of the day, where's your documentation? You've built a system. There's no documentation. How does somebody take over it? I've taken over a system without
Mm-hmm.
documentation before, and trust me, it's a lot of headache. You have to read the code and try and understand what somebody has written because you don't know how the person was feeling then. I mean, when I used to do a lot of active development, my code might change depending on how I feel. so, so you need to be able to document your code. Be able to document everything
Mm-hmm.
you do because we have a scientific process. So you can hand that document to another person and say, "This is what we built. This is what we found. Take it,
Mm-hmm.
understand it, and build on it and make it better." Okay, so we should be able to also learn how to document. All these technologies we use are being documented. If the engineers who were working on it didn't have a scientific approach, they
Yeah, go
wouldn't have
figure
thought
it
of documenting. After building it, they would say, "Oh yeah, repository in our hand. Yes, figure it out." I hate that when somebody tells you figure it out. They give you a source code and tell you, "Oh well, I inherited it. I did my part. You also take it and just figure it out." There's no documentation. So that's what we need to do. We need to be able to put all these things in practice. And once we put it in practice, it makes us a professional, it makes us an ethical engineer, and we'll be able to build software for the good of mankind. We'll be able to build software that doesn't harm the environment. That is the next thing we'll probably be talking about in another time, sustainable software engineering. You realize that you
Mm-hmm.
can actually build write code that can harm the environment, and I'll show you how that is possible. So yes,
Wow.
that's what I have for us today. So let's all take this. If there are any questions, we could probably put it in the various channels, and let's start discussing together how to become ethical engineers and how to promote the ethical practice of being
Yeah. That
software engineers.
Thank you very much,
Thank you very much,
Mr.
sir.
Chief Executive Frank. That is packed and really, really loaded. And at least we've known, at least now, if you did not learn anything, at least now you should be able to know the difference between a software engineer and a programmer. Then, of course, know that the apps you're building, software you're writing
Yeah.
is supposed to first be in the public interest. Then, of course, your employer, your manager should know that they should pay you well. You should documentation properly, and all those kind of things. If you have any question whatsoever, shoot it at me. Twitter is
Hmm.
there, YouTube is there, the podcast platform. Shoot your questions out. We'll be able to get to them and actually answer them. And actually, Mr. Frank is coming back on the show. So that is one thing we're talking about: how to write code that saves the environment, so that we don't write code that
Yeah.
everywhere is just eating up and all that. How do we write
Yeah.
code that actually productive and helps us conserve the environment? We're talking about that in future episodes. So subscribe, like, follow, whatever thing your podcast platform or your video platform gives you. Do that thing so that you get notified when that episode comes on. Mr. Frank, thanks very much for coming. I know this is our second try at recording this this episode, and I think this one is very, very much better. So if you're seeing this right now, it means we did it right.
Yeah.
Right. So thanks very much for coming. Yeah.
And credits to Sam Studios. As
Thank
you
you,
can see, I'm recording
Sam.
for Sam Studio. So um, thank you, Sam, for giving us the
Yeah, right.
equipment
So
to make this
thanks very much for
possible.
coming on the show. We'll call on you again when we are ready to record that episode.
Thank you too,
And
sir.
as I tell you, till I come your way again with another exciting episode, another guest on the show, stay safe, keep Devi, and goodbye.